to see how to evaluate trig functions not for 30, 45, 60, or multiples thereof degrees, but something like, well, for example, the sine of 75 degrees, which we don't know at this point. And we're going to do that using something called the sum and difference formulas. Now, there's 6 different sum and difference formulas, or just 3. They vary by a plus and a minus. So we have 2 for the sine of the sum or difference of 2 angles that we know the value of the trig functions for, 2 for cosine, and 2 for tangent. So let's begin. The first one is the sine of 75 degrees. Now, we don't know the value of the sine of 75 degrees, but we do know the value of the sine of 30 degrees plus 45 degrees. So what I can do is I can use this fact and the fact that the sine of u plus v equals the sine of u plus the sine of, or times the sine of v plus cosine of u times sine of v. So let's set u equal to 30 degrees and v equal to 45 degrees and substitute into our equation. So what we're going to have here is we're going to have the sine of 30 degrees times cosine of 45 degrees plus the cosine of 30 degrees times the sine of 45 degrees. Now I can evaluate each of these and simplify the result. The sine of 30 degrees. Now it might help if you have your unit circle handy, which is actually on the front cover of your note sheet, or take half root 2 over 2, root 3 over 2, along with all students take calculus to evaluate these 4 trig functions. Now remember, the values of the sine function go from left to right, and cosine go from right to left. So the first one, sine of 30 degrees is, or has a value of 1/2. And the cosine of 45 degrees, has a value of root 2 over 2. Cosine of 30 degrees, now we're going backwards, so up here, cosine of 30 degrees is root 3 over 2, and sine of 45 is root 2 over 2. So all we have to do is simplify this a little bit, and we can do that by multiplying. Since we're multiplying fractions, we multiply the numerator and denominator straight across. So 1 times root 2 is root 2, and 2 times 2 is 4. And in my second part of the expression, root 3 over 2 times root 2 over 2. Square root of 3 times the square root of 2 is the square root of 6, and 2 times 2 is 4. Now the nice part is I already have a common denominator, so I can just put my 2 numerators together, root 2 plus root 6 over 4, and that's my answer. You can verify this in your calculator if you want by plugging in the sine of 75 and plugging in this expression, and they should come up with the same decimal. All right, next example. Let me shrink this one a little bit so I have a little bit of room here. The cosine of 165 degrees. Now, there are a couple of different ways to get 165 degrees. Let's see, you can have 120 plus 45, or let's see, 225 minus 60. Either of those expressions will give you 165. I'm going to do the 120 and 45. So I'm going to say the cosine of 165 is equivalent to the value of the cosine of 120 plus 45. Now, since I'm using the cosine function and addition again, I'm going to use this third option. So this is equivalent to the cosine of 120 degrees times the cosine of 45 degrees minus the sine of 120 degrees, the sine of 45 degrees. Now, what might help you is remembering that 120 degrees has a reference angle of 60 degrees. So the cosine of 120 is equivalent to the cosine of 60 degrees, which is 1/2, but it's in the second quadrant, so it has a value that's negative, according to All Students Take Calculus, so it's negative 1/2. The cosine of 45 degrees, that one we're good with, it's root 2 over 2. Minus the sine of 120 degrees. It's equivalent to the sine of 60 degrees, which is root 3 over 2. And since it's in the second quadrant, according to All Students Take Calculus, sine is positive. And lastly, the sine of 45 degrees is root 2 over 2. So, multiplying and simplifying, I get negative root 2 over 4 minus root 6 over 4, which is negative root 2 minus root 6 over 4. If you'll notice, all of these answers are going to have some combination of root 2 and root 6 in the numerator and a 4 in the denominator. It's just the nature of the 30, 45, 60 right triangle. Our next example, the tangent of negative pi over 12. Let's see, it might be easiest if you take negative pi over 12 and convert it into degrees. To convert radians into degrees, I multiply by 180 over pi. The pi's cancel. And if I go to my graphing calculator, 180 divided by 12 is 15. So, the tangent of negative pi over 12 is equivalent to the tangent of negative 15 degrees. Again, there's a number of combinations you can use to get 15 degrees. I just like to try to find the easiest one. So I know that 30 minus 45 is negative 15. So what I'm going to do is apply these numbers. Let's see, the tangent function with a subtraction. So I'm going to use this last and bottom expression. So I have the tangent of u minus the tangent of v. So this is, equivalent to the tangent of 30 degrees minus the tangent of 45 degrees, all over 1 plus the tangent of u. So 1 plus the tangent of 30 degrees times the tangent of 45 degrees. Now, if you recall, the values of the tangent function are root 3 over 3, 1, and root 3. So, evaluating these, the tangent of 30 degrees is root 3 over 3. The tangent of 45 degrees is 1. In the denominator, I have 1 plus the tangent of 30 degrees, again, is root 3 over 3. And the tangent of 45 is 1. Cleaning this up a little bit, I have the square root of 3 over 3 minus 1, all over 1 plus root 3 over 3. Now this is my answer, but we don't like fractions within fractions, complex rational expressions. So I'm going to choose to multiply the numerator by 3 and the denominator by 3 to eliminate my fractions. Root 3 over 3 times 3 is the square root of 3. 1 times 3 is 3. In the denominator, 1 times 3 is 3. And root 3 over 3 times 3 is simply root 3. And this is the most simplified or the best answer we can write. Let's see. Lastly, we're going to verify an identity, which we just took a quiz on in our last section. They want us to verify that the sine of x minus 3 pi over 2 is equivalent to the cosine of x. So in this expression, I have the sine of the difference of two values. If I go to my formulas up top, I'm going to use this second expression. So the sine of u minus v is the sine of u cosine of v minus cosine of u sine of v. So what I have here is I have the sine of x times the cosine of 3 pi over 2. My sine is the same, minus cosine of x times the sine of u. So the sine of 3 pi over 2. Now, going back to my unit circle, 3 pi over 2 is quadrantal. It's the angle that's has a terminal site on the negative y-axis. And on the unit circle, this point is 0, -1. Remember, 0 is the value of cosine of 3 pi over 2. -1 is the value of sine. So, to simplify this expression, sine of x is simply still sine of x because I don't know the value of x. The cosine of x is 0. Minus cosine of x is simply cosine of x. And the sine of x is -1. If I clean up this expression, sine of x times 0 is 0. And negative cosine of x times a -1 is a positive cosine of x. And we can just simplify this by writing 0 plus cosine of x is cosine of x, which is my right-hand side. So I verified that the sine of x minus 3 pi over 2 is equivalent to cosine of x. On the back side, I've already worked out a couple of examples that you can review at your leisure, with the exception of number 8. I have worked it out, but I want to explain it a little bit. On number 8, they give us an expression cosine of 42 times the cosine of 18 minus the sine of 42 times the sine of 18. Now, I don't know the value of any of those trig functions, but it's cosine of two angles minus the sine of the same two angles. If I go back up to my formulas, the cosine of two angles minus the sine of the same two angles is equivalent to the cosine of the sum of the two angles. So I can rewrite this expression as the cosine of 42 plus 18, which is cosine of 60, and we know that the cosine of 60 is 1/2. And that's it for today. If you have any questions, please send me a message in Google